Hi everyone, let's get going with part 2 of getting started. This one is, well, let's just say that by this point you should be comfortable with the rules of inference. You shouldn't be learning at this point. Those should already be memorized. Most importantly, the subderivational rules, you should have a handle on them, because now we will be nesting subderivations within subderivations. So we need to have a handle on those by this point. If you have not memorized them like the back of your hand, or better than the back of your hand, then please pause and really go study them for a long while. Okay. I'll be doing two problems, only two problems, and one is really easy, the other one's really hard, but I just want to get you going with these so you can see kind of the depth of how far we'll be going with these. Okay, so let's begin with 5.3 exercise number 1A. That is actually in your homework assignment, and they do begin this easily. In fact, it's so easy that you can tell how many steps there will be. So what we have above is what the problem states, the unit set of the conditional A then B, and then the turnstile, and essentially the sentence to be derived, A horseshoe, open parentheses, A ampersand B, close parentheses. So we know everything that you're given in this assignment, you know that these derivations will work. Essentially, we're giving you the equivalent of all valid arguments. All you have to do is show that they are valid. So what we have to do is set up what's inside the curly braces, the curly brackets. Set those, whether it's singular or plural, set those sentences as your assumptions. And the sentence to be derived, that is whatever is to the right of the turnstile, that goes at the bottom. So that's what I've done here to set up. And it is, I hope at least, it is pretty fairly obvious how to do this by this point. Take a look at the conclusion. It is a conditional. What does that mean? Well, I probably used a conditional introduction to get it. How else would you get a conditional other than a conditional introduction? So it is a very reasonable assumption to think you're going to proceed in this way. I'll go ahead and set up my subderivation for conditional introduction. What do I need to do? I need to set the antecedent of the conditional that I want. So down at number 5, I need to set whatever's to the left of the horseshoe as the assumption in this subderivation. That's why in number 2, I put in A, the antecedent of number 5. At the bottom of the subderivation, I have to put in the consequent of the conditional that I want. So number 5, the consequent is A and B. So at the bottom of my subderivation, I have to put A and B. That's just the setup. And you can see by merely setting up the rule, that is setting up conditional introduction, you're almost done. It's basically almost complete. There is only one step missing here. How do we go from 2 to 4? Very simple. We already have most of the ingredients of this conditional introduction. We just can't justify step 4. There's something missing there. It's B. That's it. You get B from lines 1 and 2, conditional elimination, and then in line 4, you merely make a conjunction. 2, 3, conjunction, introduction. And now you can see, and it's color-coded, that we can easily establish a relationship from 2 to 4. And because of that, we can end a subderivation. We establish that the assumption of the subderivation, line 2, is the antecedent of the conditional we just established. And at the bottom of the subderivation, we have the consequent. So all we do is put those there. That's it. That's how that goes. Okay. Those are the problems, or the sort of problems you'll be doing. I'm not saying it's easy, but it is certainly easier than some of the things we'll be doing next time. So you really need to master these and do them diligently, really try to achieve peak focus, really set off half an hour, or at least 25 minutes to focus on these. I want to show you what's up ahead for two reasons. One, it'll really show you kind of my thought process behind a lot of these. Not only that, you need to start kind of chunking a little more. That might be the way to put it. So let me show you a problem that's in the same page. I didn't assign it to you, but it is in that same page. I believe it's J. And well, here it is. We are given 3 sentences in the set above. I've put them where they belong on the main scope as assumptions. So there's 1, 2, and 3. There they are. And to the right of the turnstile we have A. So what we have to derive is A. So I set that at the bottom of the main scope. I need to work my way somehow from 1, 2, and 3 all the way to A. Okay, well, I'm already thinking to myself, that's a single letter, A. I don't see it anywhere in the assumptions. I see tilde A in the assumptions, but I don't see the actual conclusion. So some of the bread and butter rules, some of the rules that you think to yourself, that'll be an easy one, like conditional elimination, it seems that there are no opportunities for that particular rule in this particular derivation. So we have to think outside the box, and sometimes when all else fails, you just go for a tilde rule. So in this case, that is actually what I'll be doing. I think, I can't see any other way to do it. I'm going to go ahead and put a tilde on the sentence that I want. See if I can find a contradiction somewhere within this subderivation and say, well, if I assume tilde A, it reaches contradiction, that must mean that's false, which means that A is the case. That's how I establish A at the bottom. So at this point, you really should be familiar with tilde elimination and tilde introduction. Essentially, you derive the opposite of what you want, you derive a contradiction, you end the subderivation, and then you get the sentence that you wanted. Okay, so given that we have that as the general trajectory of the subderivation, at this point, I don't really know how long it's going to be. I actually gave myself, I did this on a piece of paper prior to building this table, and I actually gave myself the entire page. It allows for mistakes, maybe extra steps that you don't really need. And that's actually more or less the way I proceeded. I just started seeing what I can dig out now that I have 4. Well, the easy one is B. That's simple 1-4 conditional elimination. So I did that. And then I kind of got stumped. I thought, well, is there anything else I can dig out here? Not obviously. Actually, even the non-obvious opportunities, there are no other opportunities here. So when you run into a wall like that, I say, well, I guess I need another subderivation. I need more to work with. So what I decided to do here, and I won't put these on the screen right now, but I actually tried some things with assuming not B, and that didn't work out, to be honest. So instead, I just kind of went through the different if you want to call them atomic sentences of the assumptions. So I already have tilde A, that's 4. I tried something with a B, that didn't work out, tilde B actually. So I just moved to the next one, C. So what I decided to do is, let's see if I can put a tilde on C. So my next assumption, and I have to actually open this up a little more, is C for tilde introduction, to see if I can find a contradiction with C and get in the end tilde C. Now, to be honest, I didn't really have a plan at this point. I wanted to just dig out as many things as possible to see what my raw ingredients were. And I'm going to be honest with you, unless you have a lot of practice with these, oftentimes, you're going to make unnecessary steps. that just make your proof longer. But sometimes you need to dig things out just to see what you're working with, just so you can eventually find your way, stumble your way maybe onto the solution. So there's no shame in that. What I'm doing here is I'm just going to assume C, see if I can get a contradiction, and then get not C out of it. So once I've assumed C, there, number 6, I can easily get out B. I hope you can see that. Lines, it's just right there in 5, reiteration. And then I can easily get not B. That's lines 2 and 6. Is that correct? Yes. Conditional elimination. So make sure you understand that so far. Because we assumed C and we derived a contradiction, B and not B, we can end that subderivation and put not C on, let's call it the main subderivation, the one for the tilde elimination that begins at number 4. So we got not C through lines 6 through 8, tilde introduction. Okay. To be completely honest, again, at this point, I was stumped. I tried a couple of different things. They didn't work out. So whenever that is the case and you're getting a little frustrated, sure, take a break. But keep the paper nearby so you can look at it, let your mind think about it on the side, you know. Here's what I decided to do. I literally rewrote this, and I wanted to give myself, I'm stuck here on line 10, and I'm wondering to myself, what is available to me? What are my raw ingredients? So in another table that I just made on a scratch piece of paper, I wrote these down. These are all the raw ingredients that I have so far. If I'm working on line 10, I can use anything above it that's in the subderivation that I'm working on and on the main scope. So here's what I can work with. From the subderivation that I'm working on, it's tilde A, line 4, B, line 5, and tilde C, line 9. Lines 6 through 8, that was another subderivation, and that's been closed. That's over. So I can't use 6 through 8. But I can use 1, 2, 3 because they're on the main scope, and 4, 5, 9 because they're in the subderivation that I'm working on currently and above the line I'm on. So that's what I'm working with. And then I reminded myself of what I'm really looking for. What is it that I want? Ultimately, I want some sort of contradiction. I want a Q and the not Q. Basically, I want an expression of TL, a sentence of TL, and then its negation. So given that, I reinvigorated my search for a contradiction. I think I found it. Now pause and see if you can find it. Here is a little tip. Do you see the contradiction now? Line 10 is simply a conjunction, right? 4 and 9. It turns out line 10 already appears elsewhere in this derivation, but as a negation. Notice that line 3, which I'm reiterating here in line 11, it just is line 10 negated. Make sure you can see that right there. That simply is Q and not Q. But it requires that you are no longer preoccupied with kind of, you know, the workings of the symbols. By this point, you should really know TL so well that when you see line 10, you can just chunk it into one sentence of TL. And when you see line 11, you can see line 10 negated. Line 10 is Q, line 11 is not Q. And by this point, if you do enough of these problems and you never stay more than a day away from derivations, if you do that, you will be able to have a change of perspective such that where other people see basically hieroglyphics, you can see patterns. And that's what's going on here in 10 and 11. Now, it actually gets harder than this eventually, but this is a good example of the sort of thing that you should be able to do certainly by next lesson. You really work on these extensively. Okay, well, let's get rid of that. Now we can finally justify line 12. This is a long one. Lines 4 through 11, tilde elimination. That subderivation that we began all the way in line 4 has finally come to an end, the contradictions being in 10 and 11. And so we end that subderivation, and line 12 is back on the main scope where we are supposed to end our derivations. And there it is. There's a rule that justifies it. Okay. Well, you have some work to do, and I really think you should try to block out all distractions while you're doing this. You really need peak focus for this. So get working. I'll talk to you soon.